This is the Building Automation Monthly Podcast with Phil Zito, episode 138. Hey folks, Phil Zito here, and welcome to episode 138. And in this episode, we are going to be answering a question that was emailed to us by one of our email subscribers. And the question is about how does logic flow? So the question is, so Phil, I am an HVAC mechanical design engineer, and over the years, the BAS to a lot of people is kind of like a magic box. It just takes equipment and makes it work. Now, this emailer goes on to talk about how he's put a lot of time into understanding what a BAS does, but that it still can get glossed over because it's different from a lot of the other aspects of what they do, meaning that it's not something you just do engineered calculations. So he said he's been looking for a podcast or course or some sort of format that would walk him through the journey from space temperature, how it's sensed, then how it's communicated to the zone controller, where it's analyzed by some logic, and then a decision's made and it outputs power to some sort of output. And then he wanted to know kind of how that is constantly changing, how it's affecting the BAS, what that effect is having on other aspects of the BAS, and basically how all of this works. So for that email subscriber, this episode is the answer to your question. So let's begin with a concept called the Triad of Control. And that is that you have an input, some form of data source, whether that is a logical input, meaning it's some information fed from a supervisory device to the controller, or you have a physical input, which is, zone temperature, airflow, etc. And that heads into the field controller. Now, inside the field controller, you have both application-specific controllers and free programmable controllers. Now, application-specific controllers are where you do drop-down choices to pick what kind of control modes you want, and then you drop down to pick what kind of inputs you have. Now, contrast that to free programmable controllers and free programmable controllers. Try saying that 3 times fast. Free programmable controllers allow you to go and write your own kind of custom logic using either line code or graphical logic blocks. And once you've done this, then the controller is going to look at the input, look at its logic, and make a decision and drive the input or output. Now, the big difference where you're seeing application-specific versus free programmable is application-specific tends to be our smart equipment or our packaged equipment. So this is stuff where you have a rooftop or a chiller and it's got manufacturer controls already in it, and then maybe use like a Backnet card to pull data out of it, but you're limited to whatever selection is made. We don't see a lot of application-specific field controllers anymore. We're primarily seeing this technology in the actual mechanical equipment. Now, free programmable controllers are where we tend to find everything else. This is your VAV controllers, your dedicated air handler controllers that are installed by the controls manufacturer, not the stuff that comes on the actual equipment. So what's going on here is in this triad of control, we have inputs, we have our controller logic, our outputs. And it's pretty basic, right? You pick your input type, whether that is a resistive input, whether that is a dry contact, whether that is a voltage or amperage or pulse width modulating. And then you select inside the controller software typically what type of input is being used. Now, controllers will come with a variety of different inputs. They'll have things called universal inputs, and these can be voltage, these can be amperage, these can be resistance, and they're usually set by either internal software or a physical jumper that you set. This is something we cover in our BAS Startup to Checkout course, and we go through kind of how you set these things up. Then once you're actually in the software itself, so you get the manufacturer's configuration tool, you log into the physical controller, and then inside there, there's a slew of different logical graphical objects or line code that processes that input and then drives that output. A common one, specific to this person's question, would be, okay, we have zone temp. Zone temp can go into a comparator object, which says, hey, if zone temp's less than set point, we're going to put our air handler in heating mode, or we're going to put our rooftop in heating mode, or we're going to put our VAV box in heating mode. Just depends what the mechanical system is. If it's greater than zone temperature, we're going to put it in cooling mode. So that is one type of logical block. Another type of logical block is a PI or PID block, which basically calculates a 0 to 100% output that will drive things like dampers. It'll drive things like heating valves, etc. Now, that's all well and good, but let's take this a step further. Let's take a journey up the field trunk to the supervisory device. And by the way, later in this episode, we're going to come back and we're going to talk about newer advanced field controllers, both IP and non-IP, that are actually, I'm not aware of any purely non-IP field controllers that have advanced capabilities in them, meaning they have a web server built in. They have HTTPS and TLS and certificating built in. They have trend and alarm and graphics built in. I'm pretty sure that that is primarily dedicated to IP controllers. Just because I can't think of any field controller off the top of my head that does MSTP or LAN FT10 or Modbus RTU, doesn't mean that there isn't one, but it's such a hard thing for me to even remember any of them that I know it's not very common. Primarily, the newer advanced field controllers tend to fall into the IP control line, which we'll talk about that later in this episode. But primarily, we're focused right now on, let's use Backnet MSTP because it's the most common. Backnet, regardless of what you may think of it, has the greatest market share. There's no way around it. It just does. So right now we've got this field controller and it's connected to a Backnet MSTP field trunk. And what happens is that using master slave token passing Backnet protocol, it gets the token, and I'm not going to go into what the token is. You can go back and listen to our Backnet episodes. By the way, if you're looking for any of the resources mentioned in this episode, it's at buildingautomationmonthly.com/138. So as I mentioned, it goes and gets the token, which allows the controller to communicate, and then the controller will either write response, its property, or in most cases, it'll execute a write property or read property service, or a response to a write property or read property service. And in that response, the data is going to flow up to the supervisory device. Now, this is where things get a little unique because you have kind of two controls lines. You have controls lines that are pure Backnet, and at the supervisory device, you're not having to install a Backnet driver. You don't have to get a Backnet license. And then you have supervisory devices that are not pure Backnet. They come with an optional driver. So assuming that you've specified the driver, assuming that you have the driver set up, you then go and configure the communication speed. And now that supervisory device is going to be collecting data from these Backnet objects. Now, it may go and use what's called shadow objects, where the object is actually created in software, and it is then pulled and you use that shadow object, or you may just map in a raw Backnet object. It just depends on your supervisory device. But what happens now is, now that you have that object data in the supervisory device, you are enabled to do a couple more things. First, most obvious thing is the graphics, right? So the whole purpose of a supervisory device originally was as a protocol gateway. It was a way of taking serial networks, meaning our MSTP, our FT10 wired networks, and shifting them into IP or Ethernet networks. So it was a protocol translation. And we still see that in supervisory devices today. For example, a Tritium Jace will take in multiple different drivers. It'll take Backnet, it will take LAN, it will take Modbus, OPC, etc., and it converts it into Tridium speak that can be used within the JACE. And, that's something that a lot of manufacturers' supervisory devices do. But once you've discovered these devices and these objects, then you can pull them into the graphics. And the graphics allow the operator a way of interfacing with the building automation system. And this is a huge area that a lot of specifications and building automation standards miss. They don't define the expectations of the graphics. They don't define the expectations of the user. They don't list out who's going to be using the system, how they're going to be using it. They don't restrict access to graphics based on user. I mean, that's a whole episode in itself. Graphics strategy, user strategy, categorization versus roles, etc., etc. Suffice to say, though, you can pull this information into the graphics and provide a way for the end user to interface with it. And we'll talk about this in just a little bit, where we go through graphics and how a command in the graphics flows down to the field controller and ultimately affects the I/O through the logic. Then we have what is called global logic, and you see this in trim and response algorithms. You see this in optimal start algorithms. You see this in global shares of outdoor air. This is where you take any amount of data. So for example, you could take all of the zone temperature sensors and their present value, meaning their actual value for the zone temp. You could record those in a supervisory device, take the average, maybe throw out outliers, and then do a discharge air reset on an air handler's discharge air set point. These are things that happen in the supervisory device. Now you can go and do them in the actual field controller with point-to-point, peer-to-peer rather is what I meant to say. You can do them with peer-to-peer shares if your product line supports that. We've tended in the past to do global logic, where we would actually write it on the wire sheet or whatever it is you call your programming environment in your supervisory device. And that global logic would do the totalization, as I mentioned, or the averaging of the zone temps, and then the reset of that discharge air set point. Now, in addition to this, we also have the capability of adding more advanced features like trends, alarming, load shedding. All of this is capable of being implemented at the supervisory device. So this is where we take our data points, we've mapped them in to our supervisory device, and now we're performing trending, which is just the historical recording of data. We are setting up alarming, which is detecting deviations from normal conditions. And so we're doing a lot in that supervisory device. Now, at this point, in a small to medium-sized building, you're fully functional. You've got a supervisory device. It may have anywhere from 1 to 100, maybe 200 field controllers attached to 1 to 2 field trunks. But at some point, you're going to outgrow the capacity of that supervisory device, and this is where we start to utilize servers. Now, I tend to find that a lot of folks who are new to the building automation space are thrown off a little bit by servers because supervisory devices have graphics capabilities, they have trending and alarming capabilities, and some of them can even point to a database so they can actually store all of the information they need. So why do we need a server? Well, the reason why we need a server is twofold. One, it is separation of duties. Now, you don't hear a lot of folks talk about this because, quite honestly, there's a severe gap in IT knowledge in our industry. That is closing rapidly, and it's awesome to see some of the folks, in our LinkedIn group and our Facebook group who are talking about what they are doing and to see the results our students are getting from our IT course. However, we still, as an industry, have a long way to go. So separation of duties for a server, what that is the supervisory device, remember, is a protocol gateway. Its primary purpose is the collection of data. At the server, what we're going or the normalization of data, I meant to say, taking it from one protocol to another. At the server level, this is where we can go and actually run our building automation application, and we can do trending, we can do alarming, we can do scheduling, we can do graphics, and we can put all of that on the server for the sole purpose of separating that from the supervisory device. So if the supervisory device goes down, then we don't have to depend on it for graphics. Also, the capacity that that supervisory device has is increased because it's not running all of those functions. It's not slowing down because everyone's logging into it for the graphics. It also enables us to do things like campus graphics, where we can now go and create a single set of graphics and map in multiple supervisory devices to the server. Now, the server is going to be running an application, and there's kind of three types of servers. We've talked about this a lot in our past episodes, but you've got the application server, the database server, and the web server. And those three functionalities are going to enable you to work on a campus, so medium to campus size building or buildings. So whenever you go past 3 to 5 supervisory devices, that's when you tend to have to use a server. Now, I'm not going to get into all the benefits of the server, but essentially what happens is that supervisory device uses a protocol, either Backnet or some manufacturer-specific protocol like the Fox protocol, to go and send data to the server. Now, the server will go and collect that data and we'll populate it into graphics. We'll take that trend data, we'll populate it into a database. It also has advanced capabilities, which supervisory devices have as well, but you're seeing this more on the server side, and that is virtualization. So now you can run 2 instances of the server in different physical locations, and if one instance fails, it will switch over. What is an instance, by the way? An instance is just the server running. So when you turn on your computer and you're running a operating system, Windows, for example, that is an instance. So what's happening now is we've got the server, we've got our database, we maybe have some advanced services like analytics or some sort of integrations going on. And now at this point, the operator can execute a command from the graphics. Now, technically it could happen from the supervisory device as well, but we're going to focus on the server just for the journey back down this roller coaster. So what's going on is you've got the server, the operator logs in, and they log into their graphic. They go to their point object and they decide to make a command. So for example, maybe they want to schedule the box. And once they've scheduled the box being a VAV box, they've scheduled that box. Now they want to go and make sure that box turns on, and then they want to maybe change some set points. What does that look like? Well, first what happens is the operator using their interface, maybe that is some software that's running on their laptop, or they're just using a normal web browser connecting to a web server, they log in. And they log in, their credentials get sent to the server, they get authenticated, and they are able to access the appropriate data points based on their role and their categories assigned to that role. So let's assume that the categories let them see the floor plan. They go to the floor plan, they go to the box or the specific space, and they schedule it to occupied. Maybe it's a temp occupancy, whatever. Now what happens is the server sends data down to the supervisory device. And through the supervisory device, that data will communicate across the communication trunk, most likely using the write property service from Backnet. Once again, we're assuming we're using Backnet here. And it will command the occupancy point to a different state, maybe from unoccupied to occupied. That then brings on the box. That brings on the controller that controls that box, rather. What happens now is the logic inside that controller changes state. Something a lot of folks don't talk about is that we use, primarily in our industry, we use state-based controllers, meaning that you have a set of logic for the different states. At least if you're programming, you really should, if your controls solution enables you. you should be using state-based programming. We're not going to talk about state-based programming in this episode. We can definitely talk about that in a future episode. If you all are interested in it, just shoot us an email at support@buildingautomationmonthly.com. Let us know. But what happens is this data flows down to the controller. The controller then goes and switches states from unoccupied to occupied. Now that is going to look at different points. Different logic blocks are going to engage. And the field controller is now going to be looking at the occupied zone temp instead of the unoccupied zone temp set points. It's at this point where the controller is going to start to drive to the occupied zone temp set point. And it's going to make a lot of different logic choices based on this control mode, this state. Now that data that is being recorded both in reaction to this new logic is going to go back up through the COM trunk, through the supervisory device to the graphics on the server. The operator is going to see this, and this is one of the reasons why you're seeing IP controls take off, is the response time for data, both upstream and downstream, is dramatically faster. If you've ever been on a large campus and you've seen 3 to 5 minute response times on 9600 baud communication trunks, yeah, you realize how slow data can flow. Now that data's flowed back up to the server, and at the server, the operator is starting to see the zone temp change, starting to see the damper drive open, starting to see the CFM. This is one reason why in specifications and standards, folks should really specify the change rate, both COV as well as the increment rate for data what's the word I'm looking for? Not uploads. I was about to say upgrade, upload, all at the same time. Refresh is the word I wanted to use for data refresh. Now, in the past with MSTP, you couldn't really facilitate almost near real-time data refresh, but with IP controls, you can go and use settings that will allow you to have near real-time data refresh, which is really valuable. Now, you've got that data flowing back up to the operator. Maybe the operator decides, set point 74, it's not really cooling down. And so that operator, and I'm not saying this is a good idea, I'm just saying this is something that can be done. Operator decides to manually override the damper to a certain percentage. And so the operator says, it's stuck at 40%. We're going to override it to 80%. Now, once again, that command travels from the server down through the supervisory device across the COM trunk as a write property to the field controller object that also has a damper output object, and it writes to priority 8 on that damper output object. And what happens now is, since it's being written at priority 8, it overrides the priority within the actual field controller logic. Now, I realize we're talking about some advanced concepts here, but if you go back and you listen to our Backnet episodes, then you'll be able to kind of understand what I'm talking about as far as priorities and writes and overrides, etc. But the field controller now overrides that output, and the output commands itself to whatever the setting is that was overridden. That, my friends, is how data flows from a field controller to the server and back down. Now, as I mentioned, things get a little bit different when we start talking about IP controls. It's one of the reasons why I tell folks when they ask, what is the future of BAS? And I say that we're primarily going to get rid of supervisory devices, stick with IP field controls and servers, and that is going to be our primary way of functioning going forward, is because of the capabilities of the field controller. You see, the whole purpose of a supervisory device, we forget, supervisory devices weren't originally created for graphics. They weren't originally created for trends and alarming. They were originally created as protocol gateways to facilitate a client-server architecture where you had a thick client that you ran the manufacturer's software, and it would allow you to connect either to a server or directly to the supervisory device, but the thick client would actually render everything. So with field controllers, especially these IP field controllers, they have trending, alarming, scheduling, analytics, graphics all built in. And, I was talking with a customer of ours the other day and was asking him because depending on when you're listening to this, we batch our podcast episodes. So we record, every 4 Fridays, we'll record 4 episodes. And then they get edited and then they get scheduled and they go out. So we do that way. I can keep up with them because I'm running a business. But what's going on is I said to this owner, this customer of ours, and I said, I'm speaking at Honeywell Momentum on how to sell IP controls. And I asked him, I said, why are you, because I reached out to a lot of our engineer customers and a lot of our owner customers, and I said, why are you not using IP controls? And one of the things that he liked about IP controls was that it collapsed everything. It made it, one, easier to manage, and then it collapsed everything so that when they're troubleshooting, when they're working on something, they go to this one controller and everything's there. The trends, the alarms, the analytics, the graphics, it's all in that single field controller. Now, this is going to be uncomfortable for a lot of us in our industry, myself included, because I'm so used to just going to the server and looking at everything. But by actually going and segmenting these devices and making them standalone, you get a greater level of redundancy, is what him and I were talking about. So when you're actually utilizing a smart controller, I don't want to call it smart controller because regular controllers are smart. So just an IP controller 10, which another segue, IP does not mean Ethernet. IP could mean fiber, wireless, mesh, cellular, etc. But when you're using an IP field controller that has those built-in analytics, trends, alarms, scheduling, your entire process flow changes. And I look at a lot of specifications that are written for IP controls, and they're still written using the old process flow. And I don't think folks, in my experience, are addressing or updating their standards or their specifications to account for the different capabilities and workflows of IP field controllers. So for example, in this workflow, if you wanted to command something, you could, in sense, directly connect to the field controller just by going and entering its IP address, and you could go and log into that and make all your changes. Also, something to be aware of is that with newer HTML5 graphics and IP field controllers, when the system is configured properly, the way in which graphics are set up and the user interface is set up is completely different, which also is a whole nother episode because we're getting to our 30-minute time crunch here. But let's recap on what was discussed so far. So as I mentioned, we start with our input, which goes into our controller, processes data, and then commands an output. From here, it goes and follows the COM trunk up through the supervisory to the device to the server where it is visualized. And then vice versa, the server allows the operator to interface via the visualization, via the graphics, and command points, which then flow down through the supervisory device and COM trunk to the field controller, where they then go and affect the logic. And that is how controls work in a nutshell. Now, here's my ask for you, my audience. As you all know, we've done almost 140 podcast episodes here, and we put it all out there. We don't go and pitch any product. We give you actual information that you can go and apply to your day-to-day job. If you found value from our podcasts in the past, all we ask of you is that you let someone know. Find one person, maybe it's a coworker, maybe it's a customer, and tell them about the podcast. That is what we ask of you as kind of the price of admission for the podcast. We don't do commercials. We don't sit here spending 20 minutes trying to pitch you on something. We go and give you valuable insight that affects your job. And all we ask is that you share, the podcast with one person. So if you found value, just simply go and copy the link to the podcast and share that with one person and tell them why they should listen to it. So with that being said, as I mentioned, everything's available at buildingautomationmonthly.com/138. Once again, that is buildingautomationmonthly.com/138. And I appreciate all of you listening as always. If you've got any questions you would like us to answer on the podcast, please go to support@buildingautomationmonthly.com. Send us an email and we will get that into the queue of questions we have, and look forward to talking to you all next week. Thanks a ton. Take care.